Okay, so hello and welcome everyone to the YouTube channel of Infinity Learn by Sri Chaitanya, and I'm Ravindram, and today I'm going to start a new series that is of geometrical optics, or we call it ray optics, and the very first part contains reflection of light through plane mirrors. Okay, so through plane surfaces how the light is getting reflected, that we are going to understand. Okay, so let's quickly start this topic. It's a very simple thing. Students, first of all let's understand what is light. Okay, तो लाइट का नेचर थोड़ा समझने की कोशिश करते हैं. सी लाइट इज टेक्निकली एन इलेक्ट्रोमैग्नेटिक वेव. ओके और लाइट का काम क्या है? लाइट इज समथिंग विच हेल्प्स अस टू सी थिंग्स. लाइट ओके, तो लाइट की मदद से विद द हेल्प ऑफ लाइट वी कैन सी ऑब्जेक्ट्स. ओके, so what happens? Light falls on the objects and gets reflected and it enters into our eye and then brain. Then what happens? Then electrical signal is sent to the brain and then we perceive it. Okay, that this is some object, the shape of the object is like this, the color of the object is like this, different signals, and we perceive in the brain differently, right? So that happens with light. So light कहीं भी fall करेगी, reflect करेगी, हमारी आँखों में जाएगी, वहाँ से क्या होगा? Brain उसको perceive करेगा through different electrical signals और वो final perception हमें object के shape, size और उसके color के through मिलेगा, right? So this is what light does. अच्छा, tell me, can we see light? Now this is something very interesting. We can see objects with the help of light, but we are never able to see light. Okay, we cannot see light, or till now at least we are not able to see light, but we can see objects with the help of light. Okay, so let me explain you what is light. Light is an electromagnetic wave. So light is an electromagnetic wave, number one. Okay, now this electromagnetic wave is a very large spectrum. Do you know that? It starts from gamma rays up till now what you say, radio waves or radio rays, right? And even this spectrum is what? Open-ended spectrum. That means there are waves beyond radio waves here having greater wavelength than radio waves. There are light waves and electromagnetic waves having wavelength lesser than gamma rays, right? So here also we have the open-ended spectrum. Now out of this, in this spectrum, there is a very small portion which we call it as visible rays, waves or light. Okay, so or we call it as light. Now important thing is it starts from wavelength of approximately 350 nanometers to approximately 750 or 800 nanometers, right? So this is the visible range, and these rays are helping us to visualize objects. With the help of these rays only we can see objects. That means when these rays falls on an object and they get reflected back and enter our eyes, then only we can see the object, otherwise we cannot see it, right? So the perception of sight is built by the help of these particular wavelengths of light, right? So where we were saying that light helps us to visualize things, but light is not visible. Now you will say, sir, it's not possible, we can see light. No, you are not seeing light, my dear, you are seeing objects, right? If light would have been visible, then the complete space would have been lit up, right? Because the light is constantly coming from sun and it reaches earth, right? But the space in between the sun and earth is completely dark. You cannot see anything over there. Yeah, if there is any object, then you can see. If there is nothing, then it is dark. But light is there, right? So light is coming from sun to earth, it is there in the space, but you cannot see light. If you keep any object in between, okay, if you keep a planet in between, if there is any planet in between, then what will happen? Or any celestial body like moon is in between, then that object will be visible because with the help of the light that is coming from sun, but the light itself will not be visible. Anyways, let's move ahead now. So this is about light. So light is what? Electromagnetic wave whose wavelength varies from a very small value to a very large value. But which particular wavelength help us to see? This particular wavelength range, which is known as visible rays or light, it helps us to visualize any object, right? I hope this point is clear. Now the thing is, you will say, but sir, in this chapter, the name of this chapter is ray optics. Ray optics, that means we are considering light to be a ray. Okay, now let's understand under what conditions we can consider light to be a ray and under what conditions we cannot consider light to be a ray. Are you understanding? Now let's see it. See, it's all about what is the size of the object with which the light is interacting. Okay, suppose a light is interacting with a very small object, a very small object like this, whose dimensions, diameter is A, right, whose dimensions are approximately comparable to the wavelength of the light. Either it is an object or there is an opening. These things we will understand in wave optics, but I will just give you a little understanding of that topic. So either this opening is very small. So this is what? This is an obstacle in the path of light, and this is what? This is an opening in the path of the light. Okay. So whenever light is interacting with a very small obstacle or with a very small opening whose dimensions are comparable to the wavelength of the light, then one amazing phenomena happens, that is bending of light happens. Okay. Now you will say, sir, this is not anything new. Understand, when the object's dimensions are very small or the dimensions of the opening are very small, then what happens? The light will come like this. Okay, the light will come like this. If I say the light is coming like this here, and it bends around the corners. Suppose this is the screen. Okay, so what will happen? It will bend around the corners. This bending of light, that means this should be the path of the light, but it bends. This should be the path of the light, it bends. Okay, तो लाइट की जो बेंडिंग हो रही है ना यहाँ पर इस ओपनिंग में, ये बेंडिंग ऑफ लाइट, इसको हम कहते हैं डिफ्रैक्शन. इस प्रोसेस को हम बोला जाता है डिफ्रैक्शन. एक्चुअली डिफ्रैक्शन इज अ प्रोसेस विच इज शोन बाय ऑल काइंड ऑफ वेव्स. दैट मीन्स साउंड वेव्स भी डिफ्रैक्शन शो करते हैं, बट साउंड वेव्स की वेवलेंथ इतनी ज़्यादा होती है कि इनके लिए ऑब्जेक्ट्स का साइज, जो कंपेरेबल साइज होता है ऑब्जेक्ट्स का, वो भी काफ़ी बड़ा हो जाता है. तो इसलिए नॉर्मली हम अपने रूम में भी बैठे हैं तो नॉर्मल जो ऑब्जेक्ट्स हम देख रहे हैं, साउंड वेव्स इन सबसे जाकर डिफ्रैक्ट कर रही है, कोई प्रॉब्लम नहीं. But light waves cannot diffract with the objects which are kept in the room right now. It will diffract with very tiny holes or very tiny obstacles which come in between, whose dimensions are, now you see visible rays dimensions. What are the dimensions of a visible ray? What is the wavelength of visible ray? You will say, sir, the wavelength of the visible ray is like 350 to 750 nanometer. So do we have any obstacle of that size right now in our room? You say, no sir, right now in your room you have a camera, you have lightings, you have a screen, whatever. The size of these objects, even this marker, it's very huge as compared to the wavelength of light, right? So the diffraction is not possible with such big objects. Okay, so whenever the light is interacting with very small objects whose dimensions, whose wavelengths are, whose dimensions are comparable to the wavelength of the light, then what happens? This diffraction concept happens. It bends around the corners. The light bends around the corners. Are you understanding? So this is known as diffraction. Here also, if this object is in between, what will happen? It will bend right like this. Now you will say, sir, explain diffraction in detail. So don't worry, we will be understanding this topic, we will be understanding diffraction in detail when we study wave optics. So here we are studying only ray optics. Now what happens? Whenever object is interacting with a bigger object like you can say a plane mirror, right? You can say a spherical mirror, right? So whenever object is interacting with such big surfaces, like the surface of a water kept in some beaker, or light is interacting with the water which is kept on the water of the lake, or when light is interacting with a glass slab, all these objects, they are quite bigger as compared to the wavelength of light. So here what happens, when we say that the dimensions of the object with which light is interacting is far greater than the wavelength of the light, that particular point we can say, okay, you can consider this wave of light to be a ray of light. Are you understanding? In that particular case only we can consider the wave of the light or light wave as a ray of light traveling in a straight direction or rectilinear propagation. Okay, I hope this is clear. So this complete study is known as wave optics. What it is known as? This is known as wave optics. So I hope it is clear. This particular thing is wave optics, where we are dealing with the interaction of the light with tiny means so tiny, like quantum sized, okay, openings or obstacles. Okay, anyways, now let's move ahead. So when do we consider light to be a ray? We consider a light to be a ray only when it is interacting with objects of greater dimensions as compared to its wavelength. Do you understand? So when it is interacting with the objects of greater dimensions, that means the dimensions of the object must be far greater than the wavelength of the light. Then we can consider light wave to be a ray of light performing rectilinear propagation. I hope it is clear. It's very simple. So when do we consider a light ray? When do we consider a light ray? When it is interacting with objects of greater dimensions, that means the dimensions of the object must be far greater than the wavelength of light, then light wave can be considered to be a ray of light performing rectilinear propagation. How do we express it? We say this is a ray of light. And when we have a bundle of rays like this bundle of rays, this is known as a beam. Do you understand? So this is particularly known as a beam. Now what are the phenomena that we can understand through the ray nature of light? See, there are reflection, refraction. These two phenomena are majorly we can understand through ray nature of light, or when we consider light to be a ray, we can understand these two phenomena. Okay, it's not like that we cannot understand these two phenomena with the wave nature of light. That also we can do. Through wave nature of light, every phenomena can be explained except one, that is photoelectric effect. Okay, that we will study in modern physics, but here I hope it is understood now. So first thing, whenever light interacts with the surface, what are the possibilities? What will happen to light? See, whenever a light ray is coming and it is interacting with the surface, then there are three major possibilities. One is either some portion of the light might get reflected back in the same medium. Okay, some portion of the light might get reflected back in the same medium. This is the first possibility. Second possibility is when it enters another medium. See, this is medium 1, this is medium 1 and this is medium 2. It might bend and enter into the second medium, that this is known as transmission of light. Okay, light is being transmitted to another medium. Third possibility is that light comes here and gets absorbed. Okay, so how many possibilities are there? Three possibilities. Either some portion of the light can come and get reflected back in the same medium, or some portion of the light can be transmitted into another medium, or some portion of the light can be absorbed here. So depending upon this, what kind of phenomena happens when a light interacts with the surface, we can define or classify surfaces in different categories. For example, if a light is coming on a surface and almost all the light is reflected back, almost 99% of the light is reflected back, then we will say that surface is highly polished surface. Okay, so when only reflection is happening, almost we say almost 99% of the light is reflected back in the same medium, तब हम क्या बोलते हैं, तब हम बोलते हैं कि it is purely reflecting surface. And in this particular case, the best example is silver. Silver is highly, or we can say highly polished surface. Okay, reflecting surface or polished surface, best example is silver. Number 2, if it shows complete transmission, that means all the light, almost all the light, 99% light is transmitted, we call it a transparent object or transparent surface. Number 3 is absorption. So light can also be absorbed at any surface if it is coming. Okay, so some of the light can be absorbed, because what happens if suppose some object is appearing green, it clearly indicates that it is absorbing other radiations, okay, and reflecting back the green portion or green wavelength, right? Do you understand? So that's why we say that absorption is also happening there. So absorption, so if an object absorbs almost 99% of the light, then we call it as a black body. So I hope you understand. So this is the classification. So any body, whenever light interacts with any surface, there are all these three possibilities happening in different proportions, right? It might happen that on the surface of a on any surface when the light comes and interact, there might be a possibility that 40% of the light is reflected, 20% or 30% is absorbed, and remaining 30% is transmitted. For example, you stand near a glass window, okay, glass of a window, and you will see that you can clearly see the object beyond the glass, right? Suppose a tree is outside your house, you can see that tree, plus the light which is getting reflected by your face, okay, the light which is getting reflected by your face and striking the mirror, it reflects back and goes into your eyes. That means you can see your own face also. Though that image is not so sharp, okay, though that image is not so bright also, but still a very faint image you can see in the glass, right? So when you are standing in front of a glass, you can see the objects behind the glass, beyond the glass, and you can see your face as well, right? Are you understanding? And how can I say that it is absorbing? For example, if a glass pan is kept and the sun rays are coming, after some time you will see the glass pan a little heated up, the temperature is little higher. Why? That means it has been absorbing radiations also. Do you understand? So these are the three possibilities when the light ray interacts with any surface, okay. Now let's move ahead and understand reflection in detail. Now let's understand reflection. So let's take a surface which is highly reflecting, okay. So we will say that light ray comes like this, this is a kind of a vector, this is normal. So we know that it goes back in the same medium, and the angle at which it comes, it goes with the same angle. Can you see that? So either you can say these two angles are same, theta theta, or these two angles are same, phi and phi. Do you understand this thing? So generally we call this angle as angle of incidence and this angle as angle of reflection. So the very first part ये सब हम पढ़ चुके हैं, इसलिए मैं बहुत ज़्यादा डिस्कस नहीं कर रहा हूँ इसमें, ये दोनों बराबर होते हैं एंगल. दूसरी चीज़ ये है इंसिडेंट रे, नॉर्मल एंड रिफ्लेक्टेड रे. व्हाट इज दिस? दिस इज इंसिडेंट रे, this is normal, and this is reflected ray, okay. All these three lie in the same plane. So that means the angle of the incident ray with the normal and angle of the reflected ray with the normal is same. That is one thing. Second thing is they all lie in the same plane. It's not possible that the incident ray and normal lie in the xy plane and reflected ray comes like this, though the angle are same. Suppose this angle is 60 degree and the reflected ray is like this, and the angle is again the angle with the normal is again 60 degrees. It might be possible, but right now these three are not in the same plane. So what I am saying is, if these two are in the xy plane, this should also be in the same xy plane, otherwise this law will be invalid, okay. So all lie in same plane. By all, what do I mean? Incident ray, normal and reflected ray. I hope you are understanding this point, okay. It is pretty much clear. Now what is there any vector way to show it? Yes, we can do that. Sometimes some questions are asked on this particular concept in the vector form. Express the law of reflection in the form of vectors. So what you can do is you can say, see, it's very simple. We have to just say that these three are in same plane. If three vectors are in same plane, what we can do? We can say that the cross product of any two vectors, when it is done dot product with the third vector, it will become 0. That means, see, if I say vector I cross vector n, that means this is what I is incident ray vector, n is what normal vector, okay, the vector of this normal. So when these two vectors are multiplied, when these two vectors are done cross product, then what will happen? Where will be the resultant? You will say I cross n. So if this is I and vector n is here, so I cross n, I can say this is vector I, okay. So I, and this is vector n, this is the direction of vector n, this is the direction of vector I. So I cross n, it is coming in this plane which is perpendicular to vector r. So I can say if this is done dot with vector r, it will be 0. Okay, otherwise you can say like this also, vector r cross vector n, again the same thing, dot vector I will be 0, or you can say vector I cross vector r dot vector n will be 0. So this is how you can express the law of reflection over here, at least this point, at least this point. Okay, and if you want to explain this point, what will you do? You will say that I cap dot n cap must be equal to r cap dot n cap. Okay, that means what I am saying is, sorry, this is n minus of this, okay, because the angle between vector I will be this. So you will draw it like this in this case, minus I cap dot n cap is equals to vector r cap dot n cap. Okay, so when you do this unit vectors like this, when you do this, so what is this is what? This is minus I cap, this is n cap, this is r cap. Now this angle is, let's say alpha, this angle is beta. So what is this? This will be what? Cos alpha, this will be what? Cos beta. So technically alpha and beta must be same. Okay, this can also be the method. Anyways, let's move ahead now. Okay, so this is all about simple law of reflection. Clear anyone, everyone? Okay, so let's move ahead and understand some more important points about the image formation through the mirror. Okay, let's try to understand this. What happens? Suppose this is the mirror and this is the object. Okay, this is the mirror, this is the object. So what's going to happen here? This is the incident ray which is coming from the object. What will happen? It will come here and get reflected back like this. This will also come here and get reflected back like this. So these are two incident rays and these are two reflected rays. So what is the definition of object? Object's definition is the point where at least two incident rays meet or appear to meet is object. So this is definitely object because these two incident rays are actually meeting here. And what is the definition of image? Image is that point where at least two reflected rays meet or they appear to meet. So where two reflected rays meet or appear to meet, that point is known as image, right? So here I can say that they don't actually meet, but if we extend them backwards, then it appears that they are meeting here. So this is your image. Now the thing is, we have already studied in this 10th standard that if the reflected rays appear to meet at some place, we call it as virtual image. And when the rays are actually meeting here, then we call it as real object. Okay, so incident rays are actually meeting here. What is this? Incident ray. What is this? Reflected ray. Got it? So when reflected rays appear to meet at some point, it is virtual image. When reflected rays actually meet at some point, it is real image. When incident rays meet at some point, that means it's the real object. When incident rays appear to meet at some point, then it's a virtual object, right? So this is a plane mirror. Now there are some points I wanted to tell you. Now see, in plane mirror, number one, this distance, if this is x, so it will be x. So the object is formed at a distance, image is formed at a distance x inside the mirror, not behind the mirror. Image is not behind you cannot look behind the mirror and see the image. No, it is formed in the mirror. So हमको ऐसा लगता है कि जो image है ना वो mirror के अंदर बनी है. अब क्या खास बात ये है, जितना distance object का mirror के सामने है उतना ही distance image का mirror से अंदर की तरफ है. ठीक है, तो mirror के अंदर image उतने ही दूर बनेगी जितना आप mirror से दूर खड़े हुए हो. That means अगर जो और जितना, या आप बोल सकते हैं जितना दूर आपने ऑब्जेक्ट को मिरर के सामने रखा हुआ है. ओके, आई गेस इतना तो समझ आ गया होगा. ये थोड़ा इंपॉर्टेंट सी बात है और अच्छी बात भी है. ठीक है, ये डिस्टेंस हमेशा सेम होता है. अब इसमें खास बात और इमेज जो भी बन रही है ना वो हमेशा ऑब्जेक्ट के एकदम सामने बनती है। आप थोड़ा सा इस बात को भी समझो। तो दो बातें यहाँ से निकल कर आती है जो we can derive two important points from here, and what is the first point that we can derive is that if this is object, this is distance x, then image will definitely be formed at the same distance x inside the mirror, right, inside the mirror. तो रियल ऑब्जेक्ट है, उसकी वर्चुअल इमेज बनी है वो भी मिरर के अंदर उतनी ही दूरी पे जितनी दूरी पे ऑब्जेक्ट मिरर के सामने खड़ा हुआ है। आर यू अंडरस्टैंडिंग? Okay, it's very simple and very easy. Now look here, one more thing is that image is always formed in front of the object perpendicular to the surface of the mirror, right? That means next point which I'm going to say is this. See, it doesn't happen like this. It's not possible that object is here, okay, object is here and image is formed here. Okay, it is not possible. The line joining the object and the image cannot be at any angle other than 90 degrees. It is never possible. So this is a wrong case. It's not possible. So what is the case that is possible? That the image should always be formed exactly in front of the object plus perpendicular to the surface of the mirror. So जो image बनेगी अगर ये ऑब्जेक्ट है तो इमेज जो है ना बिल्कुल यहाँ बनेगी ऑब्जेक्ट के एकदम सामने 90 डिग्रीज, और ये जो लाइन होगी ना दिस इज एट 90 डिग्रीज और परपेंडिकुलर टू द सरफेस ऑफ द मिरर. सो दिस इज ऑल्सो वेरी इंपॉर्टेंट. अब आप बोलोगे सर आप इस पॉइंट को इतना क्यों उठा रहे हो, इसमें ऐसा क्या खास है? अब देखो, ओके लेट मी टेल यू. यू कैन से मान लो कि ये ऑब्जेक्ट है और ये मिरर है. अब आप बोलोगे सर ऑब्जेक्ट जहां है उसके सामने ही इमेज बना दो, राइट? वी कैन से, यू कैन से दैट, देयर इज नो इशू. यू कैन से सर दिस इज ऑब्जेक्ट एट अ डिस्टेंस x, यहां पे बना दो इमेज. बट ये गलत है भाई. ओके स्टूडेंट्स, दिस इज रॉन्ग. यू कैन नॉट डू दैट. दिस इज एब्सोल्युटली रॉन्ग. सो वेयर विल द इमेज बी फॉर्म्ड? You will say sir we have to go perpendicular to the mirror. So if this distance is y, this distance is y and this is your image. Are you understanding? So this has to be understood. This is right and this is wrong. So you cannot do that. So अगर मैं ये बोलता हूँ, if I am saying that image is always formed in front of the object, yes, right, image is always formed in front of the object, but the line joining the object and the image should be perpendicular to the surface of the mirror. This is something very important. Okay, I hope you understood. Now let's see if you can answer this. One more case, sorry, one more case is there. Suppose this is the mirror and you are, this is the object. Suppose this is the object. Now where is the image formed? आप बोलोगे सर इमेज बनेगी नहीं. There might be some students who can say sir image will not be formed. I will say why? You will say sir there is no mirror in front of me. Mirror is there. How can you say that the image is formed? Mirror is there. I cannot see myself. Right. You are partially right, partially wrong. Image will be formed. That means you are wrong. Image will be formed. This is right and you are wrong. But you cannot see yourself right now. Yes, that might be true. How? See, what happens students? What is happening here? If you want to draw, want to draw, you will say, okay, extend the mirror. Extend this line, okay? This, again our condition. This is the image. You will say, sir, this distance is, if this is D, this distance will also be D and this will be image. अब डाउट यार आपको इमेज बनी कैसे सर? ओके यार इमेज बनाने के लिए हमको इस बात की थोड़ी ना जरूरत है कि मिरर सामने ही ऑब्जेक्ट. इज इट नेसेसरी दैट मिरर शुड ऑलवेज बी इन फ्रंट ऑफ द ऑब्जेक्ट? नो. देखो बहुत सिंपल सा केस आप समझो. ऐसे ये आई रिफ्लेक्टेड रे मान लो, ठीक है, और अब आप क्या करो, ओके कैन यू सी दिस? ये इमेज, ये रे ऐसे चली गई यहाँ पर, ठीक है, गॉट इट? सो दिस इज रे 1 which is got reflected here, right? Now let's take another ray. At this point, so these are the two reflected rays. Can you see that? These are two reflected rays which will never meet each other because they are diverging, but if you extend them backwards, they appear to meet here. So this is again a virtual image. Now the problem is, my dear, you are right that you cannot see yourself, because if you are the object and here you have your eyes, you cannot see yourself because all the reflected rays are going here. But if your friend is standing here, suppose if some of your friend is standing here, definitely these rays are going in his or her eyes, then he or she might be able, he or she will definitely be able to see you, and he will say that I can see you as well, and this, at the same time I can see this image also. So if I say that this is the image, this is a mirror, this is a mirror, here till this point the mirror is here, till this point is the mirror. Suppose this till this point, this particular portion is the mirror. Suppose, just imagine this particular portion is the mirror and I am standing here. So definitely what will happen, I will say my image will be formed, but I cannot see my image, right? I cannot see my image right now, because let's say that this portion is mirror, okay? So I cannot see myself, but my image will be formed, and who will be able to see me? Suppose here my friend is standing, suppose at this point my friend is standing, and he will say, sir, I can see you as well as I can see your image in the mirror, because he can see directly this object also as well as he can see the rays also. Are you able to understand? That means this particular person will be able to see the image and you both, but you are not able to see yourself because the reflected rays are not coming back to your eyes. But when you stand in front of the mirror, what happens? There is a pair of rays which come directly to your eyes. The rays are also coming to your eyes as well. The reflected rays are coming into your eyes, that's why you are able to see yourself in the mirror. If the reflected rays are going everywhere except your eyes, you will not see yourself, right? I hope this point is clear. Now one important case I want to tell you. Let's take this case. Suppose this is a mirror and this is an object, right? Or let's just wait. Suppose, let me take a case here. Suppose this is a mirror and somehow the incident rays are coming like this. They are reflected from some place. Suppose they are reflected from some spherical mirror and the incident rays are coming like this. Can you see that these are incident rays? Now in their path you have kept a plane mirror. So these incident rays wanted to meet at this point and create an object here and create an image here, okay? So technically this image which was being formed by these two rays becomes an object for this mirror. Are you understanding? This is a plane mirror and let's assume that with the help of some, you know, concave mirror, concave mirror, you all know. So rays are coming like this. Suppose a parallel set of rays come like this and they finally meet at focus. Everybody knows that. You have studied this in 10th standard, so you must be knowing this thing. If in this path I keep a mirror here, then what will happen? This image will become an object for this mirror. Are you understanding? This image will become an object for this mirror, and what kind of object? A virtual object. So this is what? This is a virtual object. So this is a virtual object for what? For this mirror. Now what will happen? But these rays will get reflected from here itself like this and they will meet here. So this is what? Now these are reflected rays which are actually meeting at a point, right? So we will say this is an real image. So अब यहाँ से एक point और clear हो जाता है, क्योंकि अभी तक आपने ये मान लिया होगा सर प्लेन मिरर जो होता है वो बस वर्चुअल इमेज बनाता है. बिल्कुल सही है, रियल ऑब्जेक्ट्स की. ओके, If the object is real, it will form virtual image, no problem. But if the object is virtual, it will form a real image. If the object is virtual, it will form a real image. राइट तो प्लेन मिरर दोनों काम कर लेता है. तो प्लेन मिरर भाई रियल इमेज भी बनाता है, वर्चुअल इमेज भी बनाता है. ये बात बिल्कुल क्लियर कर लो, अपने दिमाग में बैठा लो. रियल इमेज भी बनाता है, वर्चुअल इमेज भी बनाता है. ठीक है, बस ऑब्जेक्ट कैसा है उस बात पर डिपेंड करता है. अगर आपका ऑब्जेक्ट रियल है तो वर्चुअल इमेज बनाएगा, अगर आपका ऑब्जेक्ट वर्चुअल है तो रियल इमेज बना देगा. इज इट क्लियर? सो वी हैव लर्न सो मेनी थिंग्स अबाउट प्लेन मिरर टिल नाउ. लेट्स मूव अहेड नाउ. Okay, let's do a simple concept. Let's understand this. See, this is a plane mirror, and let's say this is a ray coming here. Okay, now this is the normal, right? Very simple question I am taking. I am just taking a very simple concept here. Suppose this angle is, let's say this angle is yes, let's say this angle is 60 degrees. Okay, so where is the reflected ray? You will say, sir, this is the reflected ray. Let's say reflected ray 1. This is incident ray. This is N1. I will tell you why I am saying this. So what is this angle? You will say, sir, this angle will also be 60 degrees. Now the question is, if mirror is, sorry, if incident ray is rotated by 10 degrees clockwise and anti-clockwise, how will the reflected ray rotate? By what angle? Okay, this is the question. Second part of the question is, if mirror is rotated by 10 degrees clockwise and anti-clockwise, same question, how will the reflected ray rotate? How will the reflected ray rotate? Now this is a pretty good question now. Okay, let's see it. So let's understand the first part. Okay, so we'll have to draw a lot of diagrams here, so please remember this diagram, right? So let's begin. Part number 1. See, if you rotate it like this, see, this is the normal, this is the mirror, and this is your incident ray. So initially it was at 60 degrees and now it is at 50 degrees. Obviously, if you rotate it in this direction, if you rotate in this, you know, what is this sense? This is clockwise sense, okay? As compared to this point, if you are rotating it clockwise 50 degrees, so what will happen to the reflected ray? It will also rotate by 50 degrees, but in which direction? That is something important. See, this was the initial value 60 degrees, and initially it was also 60 degrees. Now you see, you rotated reflected ray by 10 degrees clockwise, but reflected ray also rotated by 10 degrees anti-clockwise. Do you understand this thing? So if you are rotating the incident ray clockwise by some angle, the reflected ray will also rotate by the same angle but in the opposite direction, that is anti-clockwise. So if you try to bring the reflected ray closer to the normal, if you try to bring the incident ray closer to the normal, the reflected ray will also try to come close to the normal. Are you getting this? Is it clear? Very important. Now second case, let's take this. If you say, that means we can assume that reflected ray moves with the same angle but in the opposite direction. So if this is 60 degrees, so reflected ray was here 60 degree. Now let's change it. Suppose it comes here like this. Now at what angle? 70 degrees. So definitely according to the law of reflection, it will go by 70 degrees. So what have you done? You have rotated it by 10 degrees anti-clockwise, and the reflected ray also got rotated by 10 degrees clockwise. Can you see that? So our point is valid. So if you rotate the incident ray by an angle theta clockwise, reflected ray will rotate by the same angle theta anti-clockwise in the opposite sense. Is it okay? Okay, yes or no? This is very important. Now let's understand the second part. This is something, this is lovely, lovely part. Okay, let's come here, understand. Next thing is, suppose this is the mirror, suppose this is mirror, right? And let me fix the incident ray first, because here the incident ray is not rotating, and let me fix this normal also. Okay, so this is incident ray, this is the first normal, because if you are going to rotate the mirror, then the normal will also rotate. Okay, this is pretty much easy. Now let's rotate the mirror by an angle 60 degrees, right? Sorry, 10 degrees. So let's rotate it by 10 degrees. So what will happen? The normal will also rotate by 10 degrees. Can you see that? Now this is your second normal. Now let me draw the reflected rays. This was your initial reflected ray R1, which was at an angle, if this was 60 degrees, this was 60 degrees. Can you see that? Now next time be very careful, students. I am going to use different colors. Next time, this is the normal and this is the reflected ray. Now what is this angle? You will say, sir, 70 degrees. So next time with this normal, the reflected ray will go like this here, and you will say, sir, this angle will be 70 degrees. Can you see that? This is R2. Is R2 visible? This is mirror, okay? So this is first position of the mirror, this is second position of the mirror. So we have not changed the position of incident ray, but mirror rotated by 10 degrees, normal rotated by 10 degrees, and this is what the condition is. Now what is the angle between these two reflected rays R1 and R2? Let's see. You will say, sir, exactly, remember this. You will say, 1 minute, this is N1, right? Now you will say, sir, initially what was the angle? What is this complete angle? You will say, sir, this was 60 degrees. Now finally, what is this angle? You will say, sir, it is 70 plus 10. 70 plus 10, that is 80 degrees. So what is this angle? Can you see that? This angle, let's say this angle. So you will say, sir, this angle will be 80 minus 60, 20 degrees. Do you understand? So you will say, if mirror rotates clockwise by 10 degrees equals to theta, reflected rays will also rotate clockwise by 20 degrees, that means 2 theta. So we can assume if you rotate the mirror in the anti-clockwise direction, same thing will happen. So if you rotate the mirror anti-clockwise by 10 degrees, which is theta, so reflected ray will also rotate anti-clockwise by 20 degrees, which is 2 theta. I hope it is clear. Now you can say that, sir, this is a permanent result, that if you rotate the mirror by an angle theta, the reflected ray will also rotate by angle, reflected ray will also rotate, but by an angle 2 theta, in the same sense, right? In the same sense. Is it clear? Let's do a question. Suppose a question is given to us. This is a plane mirror and this is a incident ray, right? So they are saying initially this is 60 degrees, right? Now question is very simple. If reflected ray is rotated by 20 degrees clockwise, and mirror is rotated by 10 degrees anti-clockwise, okay, find the angle by which the reflected ray rotates. Find the angle by which reflected ray rotates. So what will you do? You will say, sir, it's pretty easy, pretty easy. Solution, very simple. You will say, sir, first of all, reflected ray is rotated by 20 degrees clockwise. That means, sorry, not reflected ray. Oh, sorry, I have written wrong. My dear, it is incident ray. Okay, now incident ray is rotated by 20 degrees clockwise. So reflected ray will go 20 degrees anti-clockwise. Number one. If this is result number one. Result number two. If mirror is rotated by an angle 10 degrees anti-clockwise, reflected ray will rotate in the same direction anti-clockwise but by 2 into 10 degrees, that is 20 degrees again anti-clockwise. So what is the result? Overall you will say reflected ray will rotate by an angle 40 degrees anti-clockwise. I hope this result is understood by you. So students, these are few important properties of the plane mirror that we have discussed. No worries, we will discuss some more stuff in the coming lectures, okay. So that's all for today students. Thank you. Do subscribe to our channel and keep learning infinitely. Thank you for all. Thank you all.